Hello, we are Team Selfie. Our team consists of 11 members. We come from Poland and we are a part of Students' Robotic Association, KNR, which operates at the Faculty of Power and Aeronautical Engineering at the Warsaw University of Technology. We have been competing in Carolo-Cup for 4 years and we improve every year. We prioritize decreasing the weight and the price of our car. Our car has 2 independent steering axles. We can use it in specific cases to adapt to the required task. We created a custom simulation gazebo that closely matches our real testing environment. Our vehicle can follow the route automatically. We can regain manual control at every point by enabling the RC mode. We capture the image using our grayscale camera. The image is transformed to bird's eye view and the lines are approximated with polynomials. We use a PID controller to follow the middle of the right lane. When following the lane, we only steer with the front axle. If any markings in the image are missing, they are approximated using the visible lines. The points are shifted based on the width of the lane. When steering clear of the obstacle detected with our LiDAR sensor, both torsion axles are turned in opposite directions. When the vehicle is on the left lane, the right lane is monitored with the LiDAR sensor to avoid hitting an obstacle when returning. The raw camera image is processed using an edge filter to detect giveaway lines. The vehicle stops at the distance specified and starts looking for an obstacle at the intersection. When both sensors, camera and LiDAR, do not detect an obstacle at the intersection, the vehicle decides to go through. Candidate parking spots are identified utilizing the detected boxes with the ROI and the left parking zone borderline. We steer with both our axles parallel to tack into the parking spot. We utilize the encoder readings to ensure that we finish the maneuver inside the chosen parking spot. We will present how our software management process helps us to solve problems. We will assume that our car tends to stop too far before the intersection stop line. First, we analyze the problem. We try to find its source. We search our private Trello board to find any previously done task that had any relevance to this problem. If we find it, we can try the same approach. If the problem hasn't been encountered before, we select the components that are most likely to have an influence on this problem. In this case, there could be multiple causes: stop line detection node, intersection handling task, or a possible camera miscalibration. We analyze the interface between nodes documented in README files and run the system in debug mode. That adds visualization and shows the logs. We then discuss what is the most probable cause and solution of the problem as a team and choose an assignee that has the most experience on this subject. We create a Trello task in order to monitor the progress, and whenever there are problems we discuss them and try to help each other through Slack or in small online meetings. To be accepted, a solution has to pass multiple stages of testing and verification. The change has to be also properly documented in a README file. First, the code is built and analyzed statically in our continuous integration pipeline. Next, one other team member has to review and accept the change. Afterwards, the solution is tested in the simulator and merged to the develop branch. Once a full release is ready, the code is verified in on-car tests and merged to the master branch. Thank you for watching, we hope to see you next year.